4.2. All right, in the last video, the audio cut out at the end, so I'll redo the big end of the last video, and then I'll continue on with limits of functions. There's a second one where I forgot the coffee and it turned old. All right, the limits we're now going to do are infinite limits, which means infinite limits at finite values, or at finite, let's do finite values, which means x is still going to approach a value and f of x is going to blow up. And so what that means is that's a sort of the lie that we're going to use, or right equals infinity or equals negative infinity. It means it can get arbitrarily large value positive. It's going to blow up this way, or it's going to get arbitrarily large negative. It's going to blow downwards as x tries to approach a value, possibly from above or below the left-hand limits or the right-hand limits. The best way to describe this is with the three classic functions that I use, the Atari functions with that picture. So the three cases, before I do an actual example of this again, because we already did this once, but the audio didn't work. So we'll drink some coffee. We'll do this. The three pictures we have are this one, and this one. So first of all, we have to recall that the left-hand limit equals the right-hand limit if and only if the limit exists and they're all equal to the same value. And they're all equal. And so, but that technically speaking, even now we can have L is equal to plus or minus infinity is what we're going to add. So we're going to cheat and write equals infinity for those two, or negative infinity, even though it doesn't really equal that. What we're describing is, I'm going to describe at 0 here. So in this one we have different behavior. This one we're both going to positive infinity. They're blowing up at arbitrarily large positive. Here we have that they're getting negative on both sides of 0, so regardless of which side we do that. And then now what should we do? Let's remind ourselves what those functions were. This is 1 over x, this is 1 over x squared, and this is negative 1 over x squared, where I've reflected about the x-axis. What does that say now in each of the limits? Here, I would say that the limit as x, just from the picture, as x approaches 0 from above, is of f of x of 1 over x, is positive infinity. It blows up arbitrarily large positive. But the limit as x approaches 0 from below of 1 over x is blowing up negative, is equal to negative infinity. And that's how we're going to decide. I know the jig is up. There's no algebra that can get me out of this. What we have to say is this expression negative below 0 and less than 0? Yes, x is less than 0, so 1 over x will still be less than 0. And so this is going to get arbitrarily large negative. Because the left-hand limit is equal to negative infinity, which doesn't equal positive infinity, which is the right-hand limit, we would say that this limit does not exist. The limit as x approaches 0 of 1 over x does not exist, because we had to check the left and the right limits still, but because we got different values, even though it was negative infinity, positive infinity, we say does not exist. Here, what we're going to get is the left-hand limit is equal to the limit as x approaches 0 from below of 1 over x squared, which is going to approach positive infinity, because even though x is less than 0, if I multiply by x here, that will say x squared is larger than 0, so 1 over x squared is larger than 0, always from the left or the right. So the left-hand limit equals the right-hand limit, which equals the limit, so we'll say here that the limit as x approaches 0 of 1 over x squared is equal to positive infinity, which means, technically speaking, on both sides as we approach 0, it gets arbitrarily large positive. It's sort of a lie that equals, but we'll tend towards there. In the last one, it's going to be upside down. The left-hand limit equals the right-hand limit, which equals negative infinity. So we'll say that the limit as x approaches 0 from above or below of negative 1 over x squared is going to approach negative infinity, which means they both go down on either side of 0. That's what's happening. Now let's try an actual example of this. example. Compute or state why it does not exist. The limit as x approaches 0, or let's change it to say 2 of x squared over x minus 2. Should we change that to also to a squared? Do you want the limit to exist or not exist? I'm talking to myself, there's nobody here. So we'll leave it as x minus 2. This one doesn't exist. This one, the limit as x approaches 0 of x squared plus 5x over x squared, x cubed, let's say. Let's try that one, see what happens there. So there's a little bit of algebra they try to sneak in there, but it won't do us any good. That's the moral of the story. What we have now is solution. For the first one, we have the limit as x approaches 2. That's the first place I focus on. Where am I going? X squared. And then I look at the function, x minus 2. It's a problem there. I would have division by 0. This is bad. Hi, kitty. You want to be in the video? Come closer. Come closer. So what I try to do is no algebra or anything breaking that up. I just have x times x. That'll never change anything. So what I do is I switch to saying, well, let's look at the left-hand side and the right-hand side. It's because it's an odd power is actually how I'm checking this. Because this is an odd power, I think it's going to behave like a 1 over x type of guy, and it's going to do different things on either side. So from this, I say, let's look at the left-hand limit. The limit as x approaches 2 from below of x squared over x minus 2, and then let's look at the limit as x approaches 2 from above of x squared over x minus 2. I switch to looking at the left-hand limit and the right-hand limit. Don't write with red, it's hard to see. But I want to switch from that, and that should be the red flag that we do, because I can't really tell and there's a problem and there's the algebra doesn't simplify. That should be the trigger to split it into 2, the left-hand limit and the right-hand limit. Here I am x, for that one, x is less than 2, so x minus 2 is less than 0, so it's negative. And x squared, regardless of where I am, is always positive, so this is approaching a positive over a negative, which would be negative infinity. The jig is up, it has to blow up. I just want to know which kind of blowing up it does. For this one, come here, kitty. Are you going to be kitty? Oh, so kitty. Hi. Yeah. This one's Tom. Hi, Tom. You want to be in the video? Yeah. You're a good boy? Oh, good boy. Meow. Meow. That's a good boy. I'm going to trip over you now. You're so kitty. You're so kitty. Okay, good boy. For this one, we now see that here, x is larger than 2, so x minus 2 is positive, and x squared is always positive. So this one is going to approach a positive over a positive, which approaches positive infinity. Therefore, because the left-hand limit didn't equal the right-hand limit, we say that this limit does not exist. I don't want to rewrite it all out. So that limit doesn't exist because the left-hand limit was negative infinity, the right-hand limit was positive infinity. Those aren't equal. We're in business. For the last one we'll do in this video, for this one, there's maybe some algebra, so you start limit as x approaches 0. Is 0 a problem? Yes, it is. But then I already see that I might be able to do some algebra over x times x squared. So cancel, cancel. That gives me the limit as x approaches 0 of x plus 5 over x squared. If I switch this, it doesn't matter, regardless if I switch, but I can't see it. Maybe is 0 a problem? Yes. Does algebra fix it? To be careful, switch it to 2 limits. That should be the limit as x approaches 0 from below of x plus 5 over x squared, but it won't matter, which is equal to the limit as x approaches 0 from above of x plus 5 over x squared. What did that do? That didn't do anything, but I split it so I can get an inequality. Here, this would mean that x is less than 0, but x squared is still positive, and x plus 5 is going to be still positive. X is less than 0, but say negative 0.01 plus 5 is still going to be positive, so this is going to approach positive infinity. This one is going to do the same thing. I have x is positive, so x squared is positive, and x plus 5 is definitely positive. So this is going to also approach positive infinity. So this one is going to be equal to positive infinity, we're going to say. This is sort of a cheat, but we'll deal with limits at infinity in the next video, and then we'll be done video. Oh, then we won't be done videos. Nowhere close. We're just starting the videos again. In the next one, what we're going to do is limits at infinity. We're finally going to push the x to positive or negative infinity, and then we'll be ready for the sketching parts when we do curve sketching. But the next thing we're going to do with derivatives, etc., is derivative, or the next thing we're going to do with limits is derivatives and continuity. Let's go do that.